Okay, welcome back. Now I want to take care of these points. So I want to add an extension. Let's go to extensions, Command N, Swift file, and I'm going to call this point extension, or let's say SIMD2 extension. So let's create an extension of SIMD2 where we want to have a restriction where the scalars are floats. And now let's create a static function called default points. So this just will set up a nice grid, so rows and columns of type int should return an array of type SIMD2 float, and let's open parentheses, and we want to return some points, okay? And these points will be of type SIMD2 float. It will be an array, and I'm going to start with an empty array. And we want to return points. And we want to do something, of course, in between. So I'm going to iterate over the rows. So for row in 0 up to rows, and for column in 0 up to columns. Do something, okay? Now, initially, I didn't want rows or columns to be 1, so I added a guard statement. Rows is greater than 1, columns is greater than 1, else print rows and columns must be greater than 1. In order to avoid a certain division by 0, which will appear in a moment, and then I just returned an empty array, okay? Or actually I returned SIMD float 0, 0. However, we set our minimal row value and column value to 2, so this code should never run. Anyways, I'll leave it here, but it's technically redundant. And I'm also going to fix this in another way, okay? So first of all, I want to have a normalization for x, and this will just be columns minus 1. And I want this to be a float. And I want a y, normalize y, to be rows minus 1. Now we're going to have to do some typecasting here. So I can try pressing Control Option Command F. Didn't really do what I wanted it to do. So fix. I want them to fix both of them. So let's just enter the code instead of hoping that the compiler will do the work for us. Okay, because I want the sum of each row to be equal to 1. So this is some kind of normalization that we'll have. And normalization usually means to divide by some value. Okay, so I'm going to set x equal to float of column, not columns, divided by normalize x. Now notice that if columns equals to 1, we're going to be dividing by 0. Okay, now this ensures that columns is not 1. Now I wrote x, I should say let x. Similarly, I can do let y equal to float row normalize y, and this will ensure that it's a value between 0 and 1. And finally, I want to append this point. And you'll see that when we'll create an actual mesh, this will just set things up nicely. So SIMD2 float, and let's enter x and y. and I need to capitalize SIMD2. Now, actually, this guard statement requires that both rows and columns is greater than 1, but maybe I don't mind if one of them will be equal to 1. So actually, in practice, what I decided to do, and again, this case is never going to happen because we set row and column to be at least 2. So I chose, instead of doing this was my initial approach, to say the following. For the normalization, so the real issue is really dividing by 0. So I said the following. If columns is greater than 1, then we're good. We can use this value. Otherwise, let's set this to 1. Same thing over here. If rows is greater than 1, then use this value. Otherwise, return 1. And we're good to go. Okay, and now let's use this extension in our main view. So we have this to do over here. And now let's actually use SIMD2 dot default points rows and columns, and I want to use new row and new column. So I can get rid of this to do over here. I could leave this as a comment, right? Create evenly distributed default points. And now let's use these points. Well, we already are using them right here, but now this code will not crash. So that's nice. Now let's jump back to the mesh model. And in certain cases, we'll be shifting the points around and we might want to reset the points. So within the mesh model, I'm going to use the extension we just created. So let's create a function called reset points within the mesh model. It takes no parameters and has no really interesting return value. And let's say self. So I want to have a function to set points. So let's actually add a self points function. So I'm going to have to, so function set points. This will take an array of SIMD2 float. And first of all, let's just make sure that points.count is equal to color point pairs.count. Otherwise, it just won't make sense. Else print length mismatch error and return. And if we made it this far safely, then we can say the following: for I in 0 to points.count, color point pairs dot, or color point pairs I, excuse me, dot x equals to points I dot x. Let's duplicate this, but just use the y value. And let's set the sort index to I. And now that we have this set points function, we can use it up here. So let's say self dot set points, and let's say SIMD2 dot default points. So self.row, comma, self.column. Great. So things are coming along. We still need the functionality to convert a mesh model to an actual mesh that can be displayed within the app. So we'll be focusing on that in the next lecture. So have an amazing day and see you next time.